In the complex operation of a wind farm, systems such as SCADA and CMMS are essential. However, a vast amount of operational knowledge resides outside these structured records. We're referring to the practical wisdom, accumulated experience, and innovative solutions that technicians develop in the field. This implicit, often undocumented knowledge is crucial for troubleshooting and optimization. It includes unique diagnostic methods, maintenance tips, and critical insights that aren't captured by current digital systems, SCADA and CMMS. The gap between what systems record and what technicians know is a missed opportunity for operational efficiency and resilience. To close this gap, we introduce the Knowledge Capture Agent. This AI-powered tool is designed to transform tacit experience into structured, actionable information. Its purpose is to turn raw experience data into valuable insights that drive operational decisions. This system allows vital information to flow from the field to predictive models and decision-making processes. Thus, practical knowledge is integrated into the wind farm's overall intelligence. It represents a shift toward more comprehensive and dynamic knowledge management. Knowledge manifests itself in two main forms: explicit and implicit. Explicit knowledge is documented, codified, and easily transferable. It includes manuals, procedures, SCADA data, logged alarms, and work orders. Implicit knowledge, on the other hand, is unrecorded experience, the tricks of the trade, and critical insights. It is the know-how acquired through years of practice and often passed on orally or through apprenticeship. This knowledge ranges from detecting subtle problems to implementing ingenious solutions. Neglecting implicit knowledge carries significant risks. First, it is irretrievably lost with staff turnover or the retirement of experienced technicians. Second, its lack of formalization prevents its effective sharing across teams, shifts, or even different wind farms. Finally, failing to capture this knowledge severely limits the potential of artificial intelligence. Predictive models and AI-assisted maintenance management systems benefit greatly from the wealth of qualitative data. The absence of this implicit knowledge represents a missed opportunity to improve the accuracy and usefulness of these tools. The Knowledge Capture Agent is a comprehensive solution designed to digitize field experience. Its primary function is to make it easier for technicians to record their observations and findings in a simple and efficient manner. This is achieved primarily through voice recordings. Once captured, the system automatically transcribes the audio into structured technical text. This process is not a simple transcription. It involves identifying and organizing key information. The agent extracts essential elements such as root causes, observed symptoms, and applied solutions. This structured knowledge is then linked to existing predictive models and operational decision-making processes. Qualitative information from technicians complements quantitative sensor data, creating a more complete and nuanced view of asset health. The fundamental principle is that where sensors cannot reach, human sensors and wisdom prevail. This agent converts the verbal experience of technicians into a new data channel. This ensures that no valuable detail is lost, transforming individual experience into collective intelligence. The Knowledge Capture Agent operates through a modular architecture composed of several specialized subagents. Each plays a crucial role in the process of transforming implicit knowledge into collective intelligence. This structure guarantees efficiency and accuracy at every stage. The recording agent is the gateway for tacit knowledge into the system. It allows technicians to record voice messages immediately after an intervention or relevant assessment. This ease of use is key to ensuring adoption and consistency in data capture. In addition to voice, this agent captures essential metadata automatically or semi-automatically. This includes the date and time of the recording, the specific turbine ID, the technician's name, and the precise location. It also records the context of the intervention, such as the system affected, weather conditions, and the resulting status of the action. Capturing this metadata contextualizes the verbal information. This is vital for subsequent analysis and linking it with other operational data. This subagent ensures that knowledge that would normally be lost is now preserved and integrated. Once recorded, the information is passed to the transcription and structuring agent. This subagent uses advanced natural language processing (NLP) techniques. Its primary function is to transcribe the audio into text, removing background noise and correcting common errors. Beyond transcription, this agent is capable of correcting specific technical errors and organizing the text into a logical structure. It identifies and extracts key elements from the technician's narrative. This includes observed symptoms, diagnoses performed, actions taken, and future suggestions. To achieve this, the agent employs NLP models tuned to a technical vocabulary specific to the wind energy industry. It also uses wind maintenance benchmarks to provide tangible representations of that knowledge. This enables a deep understanding of the technical context and accurate extraction of actionable knowledge. The result is a structured and semantically enriched text. This format facilitates its integration into databases and subsequent analysis by other agents. Thus, tacit knowledge becomes a digital and collective asset. The database enrichment agent is the system's intelligent connector. Its main function is to link newly captured information with existing historical data. This includes SCADA history, alarm logs, and previous CMMS maintenance orders. This agent uses semantic search to establish meaningful relationships between different data sets. For example, it can link a technician's observation of a specific noise to a vibration pattern recorded by the SCADA in the past. This ability to link events greatly enriches the context of the information set. By integrating implicit knowledge with explicit data, a more robust and complete knowledge base is built. This enables a deeper understanding of events and a more precise identification of root causes. Database enrichment is critical to generating actionable collective intelligence. The intelligent feedback and suggestion agent is the component that closes the knowledge loop. Based on structured and enriched information, this agent generates recommendations. These suggestions can be directed to technicians, maintenance planners, or even predictive algorithms. The recommendations are diverse and highly contextualized. For example, the agent could suggest modifying the maintenance checklist. It could propose adjustments to a turbine's operating curves to optimize its performance. It could also alert on emerging patterns that require attention. This agent not only provides information, but also facilitates a continuous learning cycle. The feedback generated by the system is based on collective experience. This enables constant improvement in procedures and decision-making. Two-way interaction between the system and users is key. Technicians contribute their knowledge and, in return, receive optimized suggestions. This fosters collaboration and trust within the platform, creating a dynamic and constantly evolving knowledge ecosystem. The implementation of the knowledge capture agent can demonstrate its value in real-world operational scenarios. The benefits are evident in process improvement and failure prevention. These cases illustrate how implicit knowledge translates into tangible results. In one specific case, field technicians noticed discrepancies in vibration sensors during high humidity conditions. This observation, initially anecdotal, was captured by the recording agent. The system processed this information and linked it with meteorological data. The suggestion agent identified a recurring pattern. As a result, a recommendation was generated to modify the maintenance checklist. A specific check was added for foggy or high humidity days. This simple inclusion, based on tacit experience, increased the reliability of the measurements. The improved checklist not only optimized procedures, it also reduced false positives and unnecessary interventions. This is a clear example of how field wisdom can refine and improve formal protocols. Another notable case involved the prevention of a critical failure. A technician recorded an observation of erratic behavior in the pitch of a turbine blade. This behavior had not been detected by the SCADA system or conventional alarms. The transcription and structuring agent identified the anomaly in the technician's description. The enrichment agent linked this information with historical data and performance patterns. The system's artificial intelligence detected an anomalous pattern and planned a remediation. The scheduled inspection revealed an incipient structural crack in a critical component. Early detection of this failure, before it became apparent to the sensors, prevented a major breakdown. It is estimated that this early intervention saved more than €12,000 in repairs and 3 days of unscheduled downtime. This case underscores the importance of qualitative information. It demonstrates how implicit knowledge can anticipate problems that current digital systems fail to detect. The technician's voice became an early warning, saving costs and minimizing downtime. The implementation of the knowledge capture agent translates into significant performance metrics. These key performance indicators, or KPIs, demonstrate the tangible value of the solution. They reflect improvements in incident detection, cost reduction, and process optimization. A 25% increase has been observed in the capture of incidents that were not logged in SCADA. This means that the system now detects and documents operational events that previously went unnoticed. Visibility into subtle or intermittent incidents has improved dramatically. Cost reductions due to unexpected failures have reached 30%. Early detection of anomalies, driven by implicit knowledge, enables preventive interventions. This prevents unscheduled downtime and serious breakdowns, directly impacting profitability. Collaboration between technicians and the system has increased by 40%. Two-way interaction improves engagement and trust in the platform. Technicians contribute their knowledge and receive optimized suggestions, creating a closed learning loop. Finally, the quality of work orders has improved by 18%. The generated orders now incorporate the tacit knowledge of the entire organization. They include contextual details, specific warnings, and recommendations based on previous experiences. This increases the effectiveness of interventions and optimizes resources. We have explored how the knowledge capture agent transforms field experience into collective actionable intelligence. The technician's voice, rich in observations and solutions, becomes an invaluable resource for wind farm operations. This system bridges the gap between traditional digital data and the practical wisdom of people. By capturing and structuring implicit knowledge, incident detection is improved, operational costs are reduced, and collaboration is optimized. Individual expertise becomes a collective asset, driving efficiency and resilience across the entire organization. Well-structured field knowledge is the most valuable asset an asset can possess. In our next video, we'll delve into a crucial aspect of modern artificial intelligence. We'll address the importance of context in AI. We'll explore how systems can not only deliver results, but also justify their decisions in an understandable way. We'll look at how complex predictive reports can be simplified for technicians to understand. This is critical to building trust and facilitating the adoption of these advanced technologies. Self-explanatory AI is the next step toward more effective human-machine collaboration.